Hi, this is Roberto, and today I'm in demo number 9 in the physics unboxing. I have no idea of what's inside. Let's see. Let's see what we have. That's a. I think this is an infrared thermometer. Yes. Yes, it's an infrared thermometer. So, okay. I think I didn't break it, but somebody broke it, and our technician made a new trigger. Okay, so this infrared thermometer, the idea is it's based on what's it called? The Stefan Boltzmann law was discovered in the beginning of the 18th century, 20th century, that all materials, depending on their temperature, they emit radiation. Have you seen the blacksmiths? You know, they heat iron and then it turns suddenly, when it's very hot, it turns bright red or even white. It's because it's due to its temperature, it's very hot, it emits light, you know? So depending on the temperature, if it's very hot, you emit infrared, and if it's cold, you emit the other. Should emit ultraviolet, depending on the temperature, right? Hot, yes. The hotter you go towards bigger wavelengths. Okay, if I remember well, the idea is that I think it's a coefficient, the Stefan Boltzmann coefficient, emissivity. Where's my pen? I don't know what it is. Anyway, because I only have yeah. This, if I remember well, Stefan was one guy and Boltzmann was another guy. How it was emissivity, I don't remember. No, was the emitted radiation, it was proportional to emissivity. Stefan Boltzmann constant and power 4, I don't remember well. Studied many years ago and I forgot. I only know I forgot the details. The basic idea is what I told you. Sorry, you can see my face. Is that depending on the temperature. So in this range, yeah, it's not very well calibrated. Because the emissivity means it's a property of how materials emit. So it is. But you can tell me that the wall is at 90 degrees and this is 90 degrees. Yeah, this is warmer, 20 degrees. The glass is at 18 degrees. Yeah, cooler than, yeah, it makes sense, cooler than, because it's goes to high side. Let's see the ball in the patio. Fifteen, 14 degrees, makes sense. If you point at the sky, the radiation is below 0 because when you increase in height, the temperature drops very quickly, you know. At 1 kilometer you have less than 0 degrees. Yeah. So this is an infrared thermometer. It's similar to one they used to now. Now it's very common to measure the temperature of your forefront, you know. The human body, when I use this, I thought the temperature of the body is 37 degrees, but yeah, no. This is the inside of the body. The outside is roughly 30 degrees, 28 now. See, 28 and 30. See, my hands are cooler. My mouth 30 degrees, not very. Like what else? What else? Yeah, so it's an infrared thermometer. Because in the range of temperature that is able to measure is between minus 50 to 270. The solids, the materials emit infrared. Okay? Yeah, but the problem, the thing that worries physicists most is calibration. It must be well calibrated or the measurement doesn't make sense. What is that? I think it's just another infrared thermometer. I think this thermometer smells like new, but it looks old. Anyway, I've never seen this thermometer before. Let me see. Wow. 775 is calibrated. I think it was retired from, no, it was quite new. 22 degrees. Let me see. Okay, this is for the light. Okay. See here, you see 0.95. This is the emissivity of the material. You need this quantity. It tells you how much of the radiation that receives is emitted. Okay. And this one can be, I think can be calibrated, changing the emissivity. And to calibrate that, you need, it's quite complicated to calibrate it. I think it has a laser, this one. So now they're very common because due to the pandemics, they have the sensors. But oh yeah, it was 30, my front. 32. 32. Okay. Thermometer 2-in-1, infrared thermometer. Okay. So now they're very common because of what you've seen. I remember bringing this to class and it was like, wow, incredible. Okay. So we saw the Stefan Boltzmann law that all the solids emit radiation due to the temperature. Okay. And yeah. And we have visible when it's quite hot, and it's less hot is infrared or thermal also. And it's also related to the Stefan Boltzmann law is related to the greenhouse effect. Okay, why? Because the Earth receives radiation from the sun, and then at night it cools down. That's the whole idea. But there's a problem if you have like CO2 or also water vapor. But water vapor is not a problem. What happens? Is like a shield for the thermal and infrared radiation that it emits the Earth at night. So it's cool to, it emits radiation and it cools down. Yeah. But the problem is that it rebounds, I think is it called that, is reflected by the CO2 in the atmosphere and goes back and warms up